we are preparing for NEET examination and doing a revision for it. Here is the application of dimensions analysis. The question says, find the dimensional formula of coefficient of viscosity eta, charge q, potential V, capacitance C and resistance R. But to help us out, they have given certain hints that we have to find out these dimensions with help of these are the facts which are given, equations which are given. With help of this are we able to find out the dimensions. Now, how to find out dimensions with help of a formula? Here you will find that F is equal to minus eta A and this. This includes eta. So our strategy will be, first we will simplify this equation in such a way that eta become a single identity on one side. Eta is to be transferred on one side and rest all the quantities on the other side. So I want to write an equation here. So if we write eta, then in this first the original equation is F is equal to minus eta A dV by dl. Okay, this one. Now let's find solution, dimensions for eta. So eta here is equal to F divided by area A dV, and this L will go on the numerator and this will become delta L. Okay, now we write the dimensions, and by homogeneity principle we know that dimension on left hand side and right hand side should be same. So dimensions of eta are equal to these dimensions of the whole thing, this. And we go for dimensions of different quantities. Force has dimensions of m, L, T minus 2, delta L dimensions of L divided by area. Area is L 2 dimensions and V is velocity L T minus 1. So this gives us dimensions of eta, which are, let's do the cancellation here. Here we have 1 and 1, 2L cancels. So T minus, here we start writing m to the power, nothing else, power 1. Remain there. Then L here only this L will come numerator minus 1, and T minus 2 and plus 1 make it minus 1. So M, L minus 1, T minus 1, these are the dimensions of eta. This is our question A done, and now we go to B, and B is asking us charge Q. And the relation given is Q is equal to I into T. So we have the same starting point, I into T. I stands for current, which is a fundamental quantity. T also stands for time, which is a fundamental quantity. So they have their dimensions which are known to us. So dimensions of Q are equal to dimensions of current, that is A, and dimensions of T time, that is T. So Q has the dimensions of A, T, and or we can write T, A. So it is one and the same thing, that is B. Now we go for C. It says potential V, and we have to use the formula U is equal to VIT, where U is energy or work done, V is potential, I is electric current, T is time. Because we have to find out V, we write here V, dimensions of VR is equal to dimensions of U divided by dimensions of I and dimensions of T. U is energy, energy is work done. So we know the dimensions. These dimensions are, I will write it here, ML, here dimensions of V dimensions of V equal to U work done ml2 T minus 2 divided by, this is I current A, and again T time T. Do the necessary cancellations and it comes to be M, then L 2 and T. This will go up and it will become T minus 3 and then A minus 1. So we get these dimensions of potential ml2 T minus 3 A minus 1. This is our answer for C. And now we go to the next quantity, and the next quantity D, yes, here it is capacitance. How capacitance is related, that also given to us. Q is equal to CV is the formula we are going to use. So Q is equal to CV, that gives us C is equal to Q upon V. So the dimensions of C, dimensions of Q we take from here, AT. Dimensions of V we take from here. This is ml2 T minus 3 A minus 1. So simplify. When we simplify this, start with m to the power minus 1, L to the power, here it makes it minus 2, L to the power minus 2, T to the power, here it is minus 3, it will go there and become plus 3 and plus 1, that is 4. ML minus 2, T plus 4, and A will have the dimensions plus 1. So that we need not write. So this is M minus 1, L minus 1, L minus 2, T to the power 4, A. These are the dimensions of capacitance. Okay. So this is our answer for D. And now we go for answer E. This is resistance R, and resistance R is known to us as resistance R is equal to, this is V upon I. And now we have the dimensions. V is having the dimensions here, M, L2, T minus 3 and A minus 1. This is to be divided by I. I has the dimensions of only A. So now R has the dimensions. First M. There is only one, L, 2 and nothing else, 2. T minus 3 and A will go here, become minus 1 and this minus 1. So A minus 2. These are the dimensions of resistance. So in this way, we have got the dimensions of all the physical quantities which were given to us in the question. And now we go to question number 2. The value of gravitational constant is G is equal to 6.67 into this Newton meter square per kg square in SI units. Convert it into CGS system of units. When we want to convert it, we know the method how to do it. So first let's write the value of G. G is equal to 6.67 is the number and rest is unit, 10 to the power minus 11. This is the number and the unit is Newton meter square kg minus 2. We write it in the standard form in place of this oblique, that is per kg square. We write it minus 2 per square. Okay. So this we have to convert to CGS system. What is CGS system? In CGS system, we must first know that Newton, in place of force unit Newton, we have the units of dynes. And Newton to dyne conversion we have already done. We should know it, that is equal to 10 to the power 5. If you don't remember it, you will have to do it once again. That is force. You will have to write MLT minus 2 for the force, and then convert SI into CGS system. That is one method. And if you remember that Newton into dynes, that is 10 to the power 5 factor, then we can do it directly. So here we will do it directly. So 6.67 into 10 to the power minus 11. In place of Newton, I want to write dynes. Then what should be my factor here? And this is known to us that it is 10 to the power 5. Now meter square. In meter square, what should I write? Centimeter square. So how much is centimeter square? Centimeter square. 1 meter is equal to 100 centimeter. So meter square is 100 means 10 to the power 2. So when we convert it into square of centimeter, square of meter, then 10 to the power 2 into 10 to the power 2, that is 10 to the power 4. Understand it? 1 meter is equal to 10 to the power 2 centimeter. So meter square is 10 to the power 2 into 10 to the power 2, that is 10 to the power 4 centimeter square. Now kg minus 2. Kg minus 2 is gram. Conversion to CGS is gram, and 1 kg is equal to 10 to the power minus 3. 1 kg is equal to 10 to the power 3 gram. So I write here 10 to the power 3. And this is to be given the power minus 2. So I write here minus 2. And now this has become gram. Yes. So now see the numbers. 6.67 into 10 to the power minus 11. Now I write here dynes centimeter square per gram square. Dynes meter centimeter square kg gram. Minus 2 minus 2. So okay, let me write it here. Dynes centimeter square and per gram square. Now what should be the number here? The here number is 10 to the power. This is 5. This is plus 4. And this is 3 into minus 2. That is minus 6. This is how you have to take it, 10 to the powers. And this has become dynes, this has become centimeter square, and this has become gram square. Kg has become gram. Now let us solve it. 6.67 as it is into 10 to the power. This is 5 plus 4, 9 minus 6. That is plus 3, and minus 8 is equal to minus 11, and this is plus 3. So that is minus 8. 6.67 into 10 to the power minus 8. And now it is CGS system. That is dynes centimeter square per gram square. This is how we could do it. So please remember, converting Newton into dyne. Write 10 to the power 5, because 1 Newton here. You can assume that this is 1 Newton. This is 1 meter square, this is 1 kg per square kg. So 1 Newton, 10 to the power 5 dynes, 1 meter square, 10 to the power 4 centimeter square, and per kg square is kg 10 to the power 3, and this whole thing is to the power minus 2. Here it is minus 2. So this is gram and this is minus 2. So gram to the power minus 2. So this is how we convert it into CGS system. Now we go to the next question. Diameter of a wire as measured by a screw gauge was found to be 2.620, 625, 630, 628 and 626. There are so many readings which are found, which are measured, and what we are supposed to calculate is mean value of the diameter. Absolute error, mean absolute error, fractional error, and all these things. So let's start it one by one. The first thing, mean value of the diameter. How do we get the mean value? The mean value is average of all of them. So let's take mean value here. I will write here mean value, and we will make addition of all of them. So this is 2.620, 2.625. Okay, let's make the total of this. That is 13.129 and divide it with 1, 2, 3, 4, 5. Divide it with 5. So it comes to be, this is 2.626. 626. So this is our mean value of the diameter. This is A. Okay, mean value. Now, next thing we have to find absolute error in each measurement. That means each measurement minus mean value. So first we write the formula absolute error. So absolute error is equal to measurement minus mean value. The difference of the two is the error. So we take here error delta A in reading number 1, in measurement number 1, that is equal to 2.620. Write the measurement minus 2.626, which is the mean value. And first we write them all. So second delta A2, that now the sign of all these values, this may be positive, this may be negative, but we are supposed to take is only modulus value. Okay, so we will take modulus value. Now these are the absolute error in each measurement. This is our question number B. Now mean absolute error, that is C. How do we get mean absolute error? We add them all. And when we add them all, it comes to 0.013 and divide it for mean absolute error. Divide it by 1, 2, 3, 4, 5. 0.013 divided by 5 and it comes to be 0.0 and this is 5 2s are 10 and 5 6s are 30. 0.026. Okay, so this we can take it this way. Now if we go for the significant figures, here the significant figures are only 1 digit. So if we go by the significant figures rule, then this will be 0.03. This is mean absolute error. Okay, now we go to fractional error number D. So fractional error number D, fractional error is error absolute divided by, I will write the formula here, absolute mean error divided by mean value. So this is what you have to remember is error divided by value. Okay, so this comes out to be absolute mean error, we have got 0.03. 0.03 and mean value is 2.626. 2.626. This is the fractional error. Okay, so if we want to remove the decimal, it will be 3/2626. Okay, This is the one, right. Now this is D. E, percentage error. How do we get the percentage error? Fractional error multiplied by 100. So percentage error, this is fractional error multiplied by 100. So this will become 300 divided by 2626%. This is the fractional error. Okay, so if we convert it into decimal, it comes out to be 0.11%. 0.11%. That is percentage error. And now we have to express the result in terms of percentage error. What is our result? Here is our result. So this is result 2.626. For the error we write plus minus. It may be positive, it may be negative, and we can write either this value, which is absolute error, or percentage. But they have asked us to express it in the terms of percentage error. So we will write here plus minus 0.11%. So this is how we write the result with percentage error. So we have done all these 6. Please remember the meaning of each and every term in this. Thank you. Here is a question. The frequency of a stretched string depends upon the tension, length of the string, and mass per unit length of the string. Derive formula and for the frequency. What we are going to do? Derive the formula. So for the derived formula, you know that ABC, power ABC method, we are going to apply that in dimensions. So first we make formula frequency F. F is equal to a constant, and then which are the quantities on which frequency depends. We take it from the question. Tension F. Tension F. Power unknown, we write it A. Okay, length L of the string. Length L of the string, power unknown, we write it B. And mass per unit length mu. Mu, and the power is C. This is mass per unit length. Here A, B, C are the unknown powers. If we know these powers, then we have got the formula. So our target is to find the value of A, B, C. And what is the principle we are going to use? That is principle of same dimensions on both sides. Okay, so same dimensions on both sides. So we are going to use it. Here we write the dimensions of both sides. This is frequency. Now the frequency has dimensions of time to the power -1. This is equal to K has no dimensions, that is constant. Force has dimensions M, L, T -2. Okay, and this whole thing has the power A. Now length L. This whole thing has the power B. And mu is mass per unit length. Mass per unit length, that is mass divided by length. So I will write it mass divided by length, and it has power C. By the principle of homogeneity, okay, first we should write the total dimensions on this side. This is mass, no, 0. Length, not here, 0. T, -1. Now here M has dimensions. Here dimensions 1 into A, that is A. Here there is no mass. Here there is mass 1 multiplied by C, that is C. So we write here plus C. So mass to the power A multiplied by mass to the power C, that is mass to the power A plus C. Now we go for second quantity, that is length. Okay, here length has power 1 into A, so we write it A. Here length has B, so multiply, we write addition in the power A plus B, and here length minus 1 into C is minus C. This is a multiplication, so this becomes addition minus C. So this is length. Then time. Here time is minus 2 into A, so we write it minus 2A. Then there is no time here. Here there is no time. So this is the only one. So we got M raised to something, L raised to something, T raised to something. These are our dimensions. Now, by the principle of homogeneity, that means each term should have same homogeneity. Okay, each term should be similar. The dimensions on both sides should be similar. So, equating similar terms. See here, mass to the power 0, mass to the power A plus C. So this gives us A plus C is equal to 0. M to the power, and they should be equal. So A plus C is equal to 0. Then we get the second equation that gives us A plus B minus C. A plus B minus C, and L to the power. Here L to the power 0, so this is also this 0. This is second equation, and now we go for third equation, T to the power minus 1, T to the power minus 2A. So minus 1 is equal to minus 2A. Now we are going to solve it here. This is the easiest one. Minus 2A is equal to minus 1, 2A is equal to 1. So A is equal to 1 by 2. If I put that A here, 1 by 2, then C, this becomes minus 1 by 2. C is equal to minus 1 by 2. Now B. If I put A here as plus 1 by 2, C here as minus 1 by 2, plus 1 by 2 minus minus 1 by 2, that will become plus 1 by 2. So B plus 1 is equal to 0. I will write it here. A has the value half plus B minus half is equal to 0. So this gives us B plus 1 is equal to 0, or B is equal to minus 1. So I write here B is equal to minus 1. So this is the result I got for ABC. Now we have already made the formula. Frequency is equal to KFL mu. Only thing A, B, C are to be inserted. So I write here relation or formula. F is equal to K, F to the power half, L to the power minus 1, and mu to the power minus half. Okay, but we go to write it in conventional way. What is the conventional way of writing it? It says that everything which has got power negative should go to the denominator, and any number which has got power 1 by 2 half, that should be within the square root. So we do it that way. So this becomes F is equal to, I will write it here, F is equal to constant, then this is yes, square root, within the square root is F, within the square root is mu, and this is L to the power minus 1. So I will write here K upon L, that is 1 upon L, L to the power minus 1, and here we will write square root. Who will be in the numerator? Positive F, and who will be in the denominator? Minus. So this is F upon mu. So this is our relation for frequency of a vibrating string, stretched string. So again I will write it. Frequency is equal to K upon L root F upon mu. We remember it by so many different notations. T upon small m, somewhere it is written, somewhere it is written as mu, anything may be like that. Okay, so this is how we solve it, and now we go to the next question. Here is another question for same formula, derive the formula. So we have to derive formula in this question. And what are the quantities? The centripetal force F acting on a particle F force circle depends upon the quantities mass, velocity, radius of the circle, and we have to derive the formula. Okay, so method of dimension. We started, which is the quantity? Force. So we write here force is equal to a constant. It depends upon which quantities? Depends upon mass m, power we don't know, so we write it a, depends upon velocity, so we write here v, unknown power b, and radius of the circle, that is r, unknown power c. Okay, derive the formula for S. Now force is one quantity, mass, velocity, r, and this equal shows that it is a equation, so the dimension on both sides of the equation should be same, dimensions of any quantity. Now we write the dimensions. Writing dimensions. Force has a dimension m, l, t minus 2, and that is equal to k has no dimensions, m is mass, m dimensions a. V is velocity, velocity has dimensions lt minus 1, and velocity whole thing has power b, so this is b. R is a radius, and radius has fundamental quantity length, so I write the dimensions of radius as length, and this will have dimensions c. Okay, now comparing, applying homogeneity. Homogeneity means what? That means on both sides the power of similar quantities should be same. Here the power is a, here the power is 1. So comparing similar terms, comparing similar quantities or similar dimensions. Here dimension mass, power 1, dimension mass, power a. So we have a is equal to 1. Good. Then we have L to the power 1. And here, okay, first we write here, sorry. I should simplify this first. So for simplifying, I write it once again. Here it is m1 l1 t minus 2. This is equal to, comparing will come later, first we are simplifying this. M to the power, here it is a, so this is a. There is no m here, no m here, so this remains as it is. Now we write L and L to the power. L to the power, this is b and this is c, so this is b plus c. Now t to the power, here it is no t here it is minus 1 into b, so that is minus b, and here it is not there, so this is complete. M, L, T all have been taken here. Now it is the time to compare. Comparing similar dimensions. And what do we get here? A is equal to 1 by this. L to the power b plus c. So b plus c. that is equal to 1. And t to the power minus b. So minus b is equal to minus 2. So 1 minus 2. Now value of a is 1, value of b, value of c. Value of b we take from here, minus minus cancelled, so b is equal to 2. Value of c here. So c is, put the value of b as 2 here, so c becomes 1 minus 2, that is minus 1. So we got the value of a, b, c, and with help of this we can now write the formula. What will be this relation? This will be force is equal to a constant m to the power 1 we will not write, v to the power b is 2, mv square, and r to the power c is minus 1. Simplifying it, all the positive will be in the numerator and negative powers will be in the denominator, and there is no half, there is no square root. So we write it simply k mv square upon r. So this is our centripetal force F. Now you don't have to bother that what happens to k. There are different methods to find k, and that is a limitation. In our dimensional method, we cannot find the value of k in dimensions. So we have to leave it, and this is our right answer. Okay, now we go to the next question. Add 6.75 into 10 to the power 3 centimeter to 4.52 into 10 to the power 2 centimeter with regards to significant figures. Now, in this first one, we find there are 3 significant figures, 1, 2, 3. In the second again, there are 3 significant figures, 1, 2, 3. So, in our answers, what operation we are doing? We are doing the operation of addition here, addition. So, in addition, our answer will have has significant figures. How many? 3. That is true. It will have 3 significant figures. But mathematically, when we are going to add them up, one is 10 to the power 3 and one is 10 to the power 2. So we cannot add them as it is unless their powers are same. Because this is 6.75 thousand and this is 4.52 hundred. So 6,000 with 400 cannot be added. So we have to do something. Either powers should be same or we should extend it. Whichever way you like. There are both ways possible. I will make it by making the powers equal. This is the minimum 2 and this is the higher value 3. So I will convert it into 10 to the power 2 and that 10 I will multiply here. So this will be 67.5 into 10 to the power 2. And this one will be 4.52. This is again 10 to the power 2. So 10 to the power 2 is common if you are doing the addition. Now, whatever is our knowledge, we have to apply for significant figures on these two. So remember, it is addition. In addition, you have to see the places after decimal. After decimal, this is one place. After decimal, these are 2 places. So which are the less number of places? This. Because this has got only one place. Don't bother for this. For addition in decimal quantities, what we are seeing for is the places after decimal. Now this 5 is significant and there is nothing here. Because this is uncertain, there is nothing here. It cannot be added with this. So this is non-significant. This 2 is non-significant. Okay, we do the addition. If you write it even, then it will be 2 and this is 0, 1, 72.02, even if we don't take anything here, but this is non-significant. After decimal, there is only one place which is significant, so we take only one place which is significant. Does it not having any effect at all? Answer is it has an effect. Had it been more than 5, then we would have changed it to 1 by rounding. But this is less than 5, so it has no effect on this, rounded off. So what is our answer? Our answer is 72.0. Make it sure to write decimal 0. Don't leave it, because this is significant here. Multiplied by 10 to the power 2. This is our answer, 72.0 into 10 to the power 2. Okay. Now we go to the next question. This question is, the radius of the sphere is measured to be 2.1 plus minus 0.5 centimeter. Calculate its surface area with error limits. That means it's a question of finding the errors. Okay. Now the radius is given, but the errors are not to be found in the radius, it is to be found in the surface area. So the first thing is, we must be able to find out the surface area in terms of radius, because radius is given quantity and surface area is to be found out. So first we write that area, surface area, which is the shape, sphere is the shape. So for sphere, surface area is S is equal to 4 pi r square. We know r is equal to radius. Okay, so this is the formula for surface area. Now if there is the measurement of radius and there is a error in it, how much will be the error in surface area? So here the error in surface area is equal to, this 4 pi is a constant, there is no error, error in r square. In 1 r there is the error delta r. So this is r multiplied by r. So in multiplication, what happens? The relative errors are added up. Remember, in addition operations, if it is r plus r, then the errors are simply added. Absolute errors are added. But if there is multiplication, then relative errors are added. Errors are added in both the cases, but in this case, relative error. So what do we get? We get a relative error in surface, and that is equal to relative error in r, but how many times? 2 times. So we get it 2 delta r by r, relative error. We also remember this formula, that if a quantity has certain power, that power will come in front and error, relative error, is to be multiplied with it. So it is the same thing. Now we have got it. So delta S upon S is equal to twice delta R by R. This is delta R, 0.5, and R, this is 2.1 is R. So this is relative error. Now if you want to find out error, that is delta S. So delta S will be equal to 2 multiplied by 0.5 upon 2.1 multiplied by S. What is this S? S is surface area, measurement of surface area, which is equal to 4 pi r square. So this S we can calculate. How? S is equal to, this is the radius without errors, so mean value. So this is 4 into pi r square, that is 2.1 into 2.1. So that value we put here, and it comes to be 2 into this point, okay, 0.5, 2.1 into 4 pi into 2.1 into 2.1. Okay, so this way the calculation is there, and now we cancel it out, and this is our answer for it. 2 into 0.5 is 1. So this remains 4 pi into 2.1. That is 8.4 pi. That is the error in surface area. So what will be our answer? If we calculate this, then it comes out to be 55.44 centimeters square. Okay, so this is the surface area. Now if you put that value somewhere here, it will be again, we will write it this way, 2 into 0.5, and that comes to be, it comes to be 26.4. This is value of delta S. Now when we have to write the surface area, then surface area is the mean area calculated 55.44 plus minus the error calculated, that is 26.4 centimeter square. So this is how it is to be done. Once again, when we calculate surface area with radius, then this is r multiplied by r square. Therefore, because of multiplication, the relative errors will be added up. So relative error of the area is 2 times addition of relative error of the radius. Relative error of the radius we have seen from here. Put the values, and this surface area we calculated from this mean position, mean value. So 4 pi r square, this comes to 55.44. Okay, that is the value of S. This S goes here. Now we calculate it. S is 4 pi, 2.1, 2.1, 1, 2.1 is cancelled. This has become 1, 4 pi, and this 26.4. This is the error, mean absolute error. So when we write the result, then this is the calculated surface area plus minus error which is calculated. So this is how we get the answer of it. Now we go to the next question. Mass and density of a solid sphere are measured 12.4 plus minus 0.1 kg meter cube. Calculate volume of the sphere with error limits. It is exactly the same way which we have done the previous question. Mass and density of solid sphere are measured. This. Okay. Volume of the sphere. Volume. Now, how can we find out the volume when mass and density are given to us? So, volume is equal to mass upon density. That is division of the two. And here we get it. Oh, there is density is not written here. I will write the density. It is 4.6 density. 4.6 plus minus 0.2, and the unit is kg per meter cube, and the mass 12.4 plus minus 0.1 kg, no meter cube here. Now the question is correct. So volume is mass upon density, so there is a division. Then error in the volume is how much? Answer is, because it's a division operation, the error in volume, that is delta V by V, is equal to the sum of the two relative errors. Relative error in volume is equal to sum of relative error in mass and relative error in density. I write it rho. This. Okay, so now let's put the values. First we calculate the mean value of volume. How do we calculate? That is, V is equal to, here mass is given to us, mean value 12.4, divided by mean value of density, that is 4.6. 4.6. So this gives us the value of volume of the material, which is 2.69 meter cube. 2.69 meter cube. Okay, so this is mean volume. Now we have to find out error. So this error delta V by V is equal to delta M by M, 0.1 upon 12.4. 0.1 upon 12.4. This I have taken from mass. Error in density divided by density. This is error in density, so I write it 0.2. The density is 4.6. 4.6. Now we do this calculation, and this calculation comes to be 0. Yes, if we do the calculation, here we have to write it that delta V is equal to this 1 upon 124 plus 2 upon 46 to be multiplied with V. V will come here, and this V is 2.69. 2.69 meter cube. So this is value of delta V, and when we calculate, it comes to be 0.14. 0.14 meter cube. So our answer, calculate the volume. We will write here volume is equal to 2.69 plus minus 0.14 meter cube. This is our answer for it. And now we go to the next question. A thin wire has length of 21.7 centimeter, radius 0.46 millimeter. Calculate volume of the wire to correct significant figures. It's a very easy question. A thin wire length is so much, radius so much, but we have to find volume. So volume is equal to surface volume is equal to area of cross section multiplied by length, and area of cross section, the cross section of wire is circular, so it is pi r square multiplied by length. Now here it is pi 3.14 multiplied by r square, that is 0.46 millimeter. So this is 0.46 into 10 to the power millimeter to centimeter, 10 to the power minus 1. Square of it multiplied by length, and that is 21.7. Now this is centimeter, this is also centimeter, so we get the answer in centimeter square. We do a little calculation of it, and it comes out to be 0.1443. 0.1443 centimeter square. Okay, centimeter, centimeter, centimeter square. This is our result of this whole multiplication. But now we have to find out the correct significant figures. This is a operation of multiplication. So we see here that how many significant figures were there in the given measurable quantity, that is R and L. We will not count pi because it is a constant. Anyway, R has got this 1, 2 significant figures. L has got 1, 2, 3 significant figures. So which are the minimum significant figures? Answer, 2 minimum significant figures in one quantity. Therefore, answer will have also 2 significant figures. So, given data has minimum 2 significant figures. Two significant figures. Therefore, answer is equal to 0.14, and we drop this 4. Because we are going to drop this 4, which is less than 5, then we don't have to compensate 4. So it will remain 14 only. So 0.14 centimeter square. This is how we are going to write the answer with 2 significant figures. So this is our right answer. What we are going to find out? Oh, volume, pi r square L. This is square, this is centimeter, so this is cube. So I should write it cube. I'm sorry. This is the one, 0.14 centimeter cube. This is how we get the volume. Thank you.